that kind of gives you why this H plus and why this OH minus is so important, because it deals with water, and water, as we know, is probably the most important chemical that we deal with in the lab. So a few more quick things. I know this video is running a bit long, but I'll try and split it at an appropriate point. I want to teach you how to estimate the pH value. In order to do that, as I've said before, you're going to look at the concentration of your H+, and you're going to look at what the exponent is and take the negative of it. That will give you approximately what the pH value is. So, a concentration of H+ of 1 times 10 to the negative 3, you look at this negative exponent of negative 3 and take the negative, and that will give you a pH of exactly 3. So if you have this concentration of H+, you get this pH value. If you have a concentration of H+ of 10 to the negative 4, that would correspond to a pH of exactly 4. So you can see how this correlates in regards to the overall pH scale. And again, if it's not exactly 10 to the negative 4 or 10 to the negative 3, if it's somewhere in between, for example, if we have 9 times 10 to the negative 4, well, that would be 0.0009, which is almost 0.001, which would be 10 to the negative 3. So this pH value is nearing a pH of 3. It's between pH 4 and pH 3, and we're getting pretty close to 3. So this 9 times 10 to the negative 4 would have a pH of about right there. Getting pretty close to 3, but not quite at 3 yet. So just by looking at the exponent, you can tell approximately what your pH value is. Now, the important thing here is that since pH and pOH are in constant balance, they always have to remain multiplying to get to this same 1 times 10 to the negative 14. That means at neutral pH, your pH and pOH will add up to a value of 14, 7 plus 7. And this pH and pOH scale will always remain in balance in that way. If the pH goes down to 6, the pOH goes up to 8. 6 plus 8 is still 14. If your pH goes down to 5, and your pOH will correspondingly go up to 9, and 9 plus 5 still equals 14. So if you ever need to find out what the pH or the pOH value is, if you know one, you can find the other, because the pH plus the pOH will always equal the value of 14 that you started with in neutral water, because as one goes up, the other goes down by the same degree. So, the main point here, what we're going to do mathematically, is if you're given any of these four, pH, pOH, concentration of H+, or concentration of OH-, you should be able to calculate each of the other three. So let me show you how we would do that. If you have a solution that has a pH of 4, and you want to find each of these other values, here's where you would go. Well, you look at a pH of 4, and you would say, okay, I know that the pH is the negative log of the concentration of H+. So the concentration of H+ is going to have a value of 1 times 10 to the negative of this value, 1 times 10 to the negative 4th power. That would be our concentration of H+. We just took the pH value, took the negative of it, and put it as an exponent on base 10. So, if this is our concentration of H, that is how we get concentration of H+ from pH. If we need to find pOH, well, we know that pH plus pOH has to add up to a value of 14. So, if the pH is 4, the corresponding pOH would have to be 10, because 10 plus 4 is equal to 14. Also, if we need to find the concentration of OH-, well, we know that the pOH is the negative log of the concentration of OH-. So, if we take this number, put it on as an exponent of base 10, and take the negative of it, that will tell us what the concentration of OH minus is. So the concentration of OH minus would be 1 times 10 to the negative 10. Took this 10, put it as an exponent here, made it negative. So just from this one number of pH of 4, we could figure out all 4 of these values, and that's what we're going to be asked to do regularly. Again, I'll just show one other example at a different starting point. So if we have a solution that has a concentration of OH minus that is 1 times 10 to the negative 8, we can find all of these other values as well. So we look at this, we look at the exponent, we see this is 1 times 10 to the negative 8. So we would say that the pOH would then be 8. We just look at this exponent, we take the negative of it, that gives us our pOH value. We then know that pOH plus pH has to equal 14. So 8 plus what value equals 14? That gives us a pH of 6, because 6 plus 8 is equal to 14. And then if we need to turn this into a concentration of H+, we say the pH is 6, so we'll take that 6 and we'll put it as a negative exponent on base 10. So the concentration of H+ would have to be equal to 1 times 10 to the negative 6th. Overall, these problems aren't particularly hard once you get the hang of them, as long as you understand these scales running in reverse and understand that the value on one scale corresponds to an increased value on another scale. The problems aren't particularly hard. And as soon as you get the hang of them, you will be able to do them pretty easily, but it requires a little bit of practice and a little bit of thought. So that's all I have for you for today. Thank you very much, and I will talk to you in the next video.